Well, as always, good morning, good afternoon, or good evening pre-calc classes. We are going to finish up Chapter P here today with Section P9, dealing with both linear inequalities and absolute value inequalities. And, like it says here, we're going to go over solving both of them, writing the answer in interval notation, and I'm even going to just review back over even graphing those on a number line a little bit as well. So, if we have something like example 1 here where we have 1 minus 3x over 2 is greater than or equal to x minus 4, one thing that you certainly have as an option, if you look at this and say, hey, I don't really like the fraction there, what you can do? Go ahead, just multiply everything by 2, so 2 minus 3x is greater than or equal to 2x minus 8. Certainly not a requirement, but something that you might find as a helpful option there. So from here, let's go ahead, subtract the 2x, subtract the 2, and then we have negative 5x is greater than or equal to negative 10. Final step, divide the negative 5, and I did intentionally solve this one the way I did just to remind you that if you divide an inequality by a negative, and same thing would apply if you multiplied by a negative, you do have to flip your inequality, so x is less than or equal to 2. So, answer in interval notation, well, that's going to be negative infinity to 2. And then one other thing that I know as you work through the online homework that is also going to show up is graphing on a number line. Well, when you have a closed interval bracket, that's where we are going to use a filled in circle, and then either you can shade or certainly just draw your arrow to the left. So there is that first example. A compound inequality here, again, isolate x as the middle term. So basically you're going to solve two problems at once. To get rid of the negative 2, add the 2 to both outer values. So 3, negative x, and 0. And then this is kind of where I was saying whether you divide or multiply by a negative. So negative 1, that'll just keep it. X, negative 3. This switches to where now it says x is less than 0 and greater than negative 3. So as far as our interval goes, when you have just greater than and just less than, we will use parentheses. And setting up our number line, negative 3 and 0, when it's a parenthesis, we will use an open dot. And again, here's where you can shade in between. I'm not picky. If your past teachers had you shade on your number lines, great. If they just had you draw more like an arrow, fine as well. So that is another example there. And then one final compound inequality. 5 minus 3x is greater than or equal to 17 and less than 29. Well, again, we will go ahead, subtract the 5. And divide everything by negative 3, which once again will make that greater than negative 8, less than or equal to negative 4. I'm not real picky about you rewriting this in order as long as your interval is in the correct order, and same thing with your number line. So open dot around the negative 8, close dot at negative 4, and we can shade in the middle. All right, absolute value inequalities. Well, with absolute value, just like when we solved, you are going to have two separate problems. When you have the absolute value of x is less than a, well, what that's going to actually become is that one can be written as a compound inequality where x is greater than negative a and less than a. If you have an absolute value inequality that is greater than to start, you are going to have to have two separate inequalities. X is less than negative a or x is greater than a, which as we do a couple examples, you'll even see how that works. So for absolute value, x minus 5 is less than 2. Again, for this one, we can set up a compound inequality and add the 5. So that gives us x is less than 7 and greater than 3. So our interval goes from 3 to 7. If we do also go ahead and set up a number line, it would look like that. So other than that, final one, and here's where you'll actually see the reason that when it is a greater than, we do have to set up two separate inequalities. So subtract the 3, x is less than or equal to negative 30. Subtract the 3, x is greater than or equal to 24. So in terms of certainly your interval, negative infinity to negative 30, and then we'll use our union symbol. Not sure if we've actually talked about that yet this semester or not. And 24 to positive infinity. And so on a number line, I'm not picky at all about how evenly you space those, negative 30, 24. Since they are equal to, we'll use closed dots. I'll admit when it's an or, I actually kind of like the arrows. When it's a closed interval, I'll do shading more often than not. But that's a quick review over the topics of both just linear inequalities and absolute value inequalities.